Hello and welcome to the AICE Chemistry lecture series. In this video, we're going to look at 10.6, which is going to cover now the chlorides of the period 3 element. So if you haven't noticed the pattern, we went from the oxides to the chlorides of period 3. And this is very common for the study of inorganic, to study things in groups by what they're reacting with and what compounds they create. So in this case, we're going to look at chlorides, and we're actually going to look at chlorides for this section and the next section. So let's get started. Now, the chlorides of the period 3 elements go actually very similarly to the oxides of the period 3 elements, but the only difference is that the chlorine in these compounds is going to have a -1 oxidation number. So unlike oxygen, which is a -2 oxidation number, in this particular case, the chloride is going to have an oxidation number of -1. So we'll just put that here so we can remember. Now, when we compare electronegativities of the period 3 elements with chlorine, we have a very similar pattern that we did with oxygen. All of the electronegativities of the period 3 elements are going to be lower than that of chlorine, except for, of course, chlorine, because chlorine itself is a period 3 element. So because the electronegativity of the period 3 elements are all lower than chlorine, all of the oxidation numbers of the elements in the chlorides are going to be positive in charge. And just like with the oxides, because the elements can use all of their valence electrons to bond to chlorine in period 3, we're going to see an increase of their oxidation numbers from 1 to 2, 3, 4, 5, from sodium to phosphorus. And then the only exception to this rule is going to be sulfur. In the case of sulfur, the the oxidation number of the chloride is +2. And there's actually a second chloride of sulfur with a +1 electronegativity. Actually, let me use this a different color. So there are two oxidation numbers that sulfur can have with chlorine. In S2Cl2, the oxidation number of the sulfur is +1, whereas in SCl2, which is the more common compound of sulfur and chlorine, the oxidation number is going to be +2. So we see the same increase that we saw with the oxides, +1, +2, +3, +4, +5 in oxidation numbers, all the way up to sulfur, and then it's just +2 or +1 depending on which compound we're looking at. Chlorine is obviously not going to have a compound with chlorine, because it will just make the chloride element the diatomic chlorine. And then argon, like we said, is a noble gas, so it's not going to bond with chlorine. Now we can see here the compounds are created: NaCl, MgCl2, AlCl6, Al2Cl6, SiCl4, and PCl5. Now I should say there's also another compound of phosphorus and chlorine. Now we discussed this before. Let me get my pen here. The other compound of phosphorus and chlorine is PCl3. In PCl3, the phosphorus has a +3 oxidation number. Now again, the more stable compound of phosphorus and chlorine is PCl5, and so it's the one that fits the pattern of oxidation numbers. That's why it's the one that we see here. But there are two different compounds that phosphorus can make with chlorine: PCl5 and PCl3. Now, if we look at our compounds here, we can see again a pattern in what they are. Now, we will discuss this pattern later on in the next chapter or in the section, but sodium chloride and magnesium chloride are both ionic in nature. And that's because both sodium and magnesium are metals that are bonded with chlorine, which is a nonmetal. On the other hand, aluminum has an ionic compound or an ionic bond with chlorine, but it has covalent character. We talked about this with the aluminum oxide again, but it's even more prevalent with the aluminum chloride. And we studied aluminum chloride before. We studied aluminum chloride when we studied its dimer earlier on. And then finally, the silicon and the phosphorus compounds are all going to be covalent. Let me get rid of this PCl3 right now. So these are all going to be covalent in nature because we have either metalloid or non-metal bonding with chlorine, which is again is a non-metal. So this is going to give these compounds of chlorine their specific properties, which we'll discuss in the next section. That's really it for this section for 10.6. We'll discuss these chlorides more in depth and the reactions in 10.7 in the next video. I will see you then.